My dear student in the first secondary stage, welcome at Integrated Science Program. My name is Mr. Hani Muhammad, and now let's continue our Integrated Science Program with the first unit, Aquatic Ecosystem, Lesson 9, the effect of water pressure on organisms. I want all of you to look to this picture carefully, okay? All living organisms at great depth in oceans and are facing harsh environmental conditions, such as extremely high water pressure that require unique adaptations for survival. If you look to this picture, you can find different creatures which live deep in the oceans, like vampire squid and like goblin shark and anglerfish, giant isobod, and chimera fish. All of these kinds of living organisms, always you can find it in the deep ocean. Okay, so in the deep ocean, these organisms will expose to the high pressure. And our lesson today, we need to know first, how does water pressure affect organisms at deep water? And the second key point here, how do the physiological adaptation of these organisms help them live under this immense pressure? So we have two main questions. It's the key question for our lesson today. The first one, how does water pressure affect organisms at deep water? And how do the physiological adaptations of these organisms help them live under this immense pressure? And immense pressure here means extremely high pressure. Okay, so this pressure sure will affect the living organism and also affect the kind of adaptation of these organisms. Okay, let's go now, and we need to answer a questions which we mentioned it before, okay? And to answer this question, we need to study first the fluid and its properties. If you wanted to know more about the adaptation of the living organism according to the pressure, we need to study first the fluid and we need to know the properties of this fluid. Let's continue. First of all, what is the fluid? The substances characterized by their ability to flow and include liquids and gases. So don't forget here, the fluid here, it's not related to gas only or the liquids only, but it's related to both of them. Okay, and the main features of the fluid here, whatever gas or liquid, all of them can flow. Okay, that's very important to know. Let's read the definition again and confirm this concept. What is the fluid? The substances characterized by their ability to flow and include liquids and gases. Again, the fluid is the substances characterized by their ability to flow and include liquids and gas. Don't forget, look to this picture. We have here in the left side, this is represent the gas, and the right side represents liquids. Let's make a brief comparison between them. The gases, the size of the gas or the volume of the gas is changeable, okay? And it is fill all the containers which you found inside. And the liquid, the volume is constant, yes, but the shape of the liquid change according to the container. So the main difference here between the gas and the liquid, according to this picture, okay, the volume of the gas is changeable, but the volume of the liquid is constant. The shape of the gas is take the shape of the container as a whole, and also the liquid takes the shape of the container. But actually, let's go to know more about the differences between the gas and liquid, which both of them belongs to what? Yes, both of them belongs to the fluids. Okay? What is the difference between liquids and gases? Gases are compressible and occupy any space they are in. And here, it's very important property for the gases. It is compressible, where its volume can be changed according to the pressure exerted on the gas. Okay? But if we talk about the liquids, liquids resist compressions and therefore it maintains approximately a constant volume. So, if I ask you why the volume of the liquid is approximately constant, that's right, because liquids resist compression. We cannot compress the liquid. So, in the car brakes, we can use the liquid, okay, in the brake. Why? Because the liquids like the oil, which we use it in the car brake, okay, it is incompressible. Okay, so we have here two main differences between the liquid and the gas. The first one, gases are compressible and occupy any space they are in, but liquids resist compression and therefore it maintains approximately constant volume. Okay, you have to keep that carefully in your mind because that will help us in the next part in our lesson. Okay, let's go for another thing. And now, my dear student, let's study how the pressure inside a static liquid change with the depth. Why? Because we're going to know the factor of the pressure and how the high pressure affect the marine organisms. Don't forget, the title of our lesson today, the effect of water pressure on organisms. So all our studies and all our knowledge about the liquid pressure will help us to explain how the pressure affects the living organism. Okay? And now, my dear student, let's study how the pressure inside static liquids changes with the depth. The pressure at a point inside a static liquid. And the static liquid here means it is not a movable liquid, okay, like a liquid in a container, a liquid in a glass, okay. So there is no current, there is no movement for the liquid, okay. So this is the meaning of static liquid, okay. And now we need to know the pressure at point at the static what? Static liquid, okay. The liquid has a pressure at any point inside it that equals the weight of the liquid column above that point, and that acting on the unit of area around that point. If you look to this picture, okay, and this is the cube, it's affected by the pressure from everywhere, okay, and this pressure in the above surface here, it is equal the weight of the water column starting from the surface of the water to the surface of this body or this cube. Okay, so the liquid has a pressure at any point inside it that equals the weight of liquid column above that point acting on the unit of area around that point. Because I mentioned before, okay, the pressure, what is the pressure in a general? It is the force affecting the unit area, and this force must be perpendicular. So this cube is affecting by a force perpendicular on its surface from every side, okay, and this force causing what? The pressure. That's right. Okay. Also, If an object exists at that point, it is affected by force resulting from this pressure, and the force is perpendicular to its surface. Okay, don't forget the force, it is perpendicular to its surface. Okay, my dear student, I hope this is clear for all of you. Okay, and now let's go for another thing. Okay, the force acting on an object in a liquid is measured in newtons. Don't forget, the measuring unit for the force, it is what? Yes, Newton. Okay, the force equals the pressure times what? Times the area. That's good. Okay, but don't forget, P here, it is represent the pressure. It is the symbol of the pressure. And the measuring unit of the pressure is Newton per, yes, Newton per meter square. Okay? The second A, it is the symbol of area. Okay? That has a measuring unit equals, yes, meter square. Don't forget that. Okay, so the force here equals the pressure times the area. Excellent. That's very nice. My dear student, we need to answer this question. It's very important how the water pressure changes with the depth. Why? Because by changing the depth, okay, the living organism adaptation will be changed according to the pressure affecting their bodies. Okay, so the pressure increase, okay, as the depth from its surface increases due to the increase in the weight of water acting on the unit area at that point. Don't forget how the water pressure changes with the depth. Yes, the pressure increases as the depth increases. So when you dive in for a long distance in the water, okay, the pressure will increase and that will affect your body. So that also will affect the creatures that live in the ocean or the seas. Okay? I want all of you to look carefully for this diagram, which represents, okay, a container with three holes in three different levels. And if you look to the jet, okay, the lower jet, it's called by the stronger one. And the water here travel for a long distance. If you look to the ruler down here, okay, the ruler, we can measure the distance from the container to the point of falling the water. So the first jet, which is found in the lower part, it has the highest pressure, okay, and the above one or the first one up, okay, it has the lowest pressure where it's fall down at a point very near or very close to the container. And the middle jet, okay, it is intermediate between them. So from this we can conclude by going deeply in the oceans, okay, at the pressure of the liquid increase, okay, the pressure of liquid increase, and don't forget that. So the key question here, okay, or the key information here, the concept here, okay, it is the pressure of the liquid increases by what? Yes, by increasing the depth. And that mainly affect the living creatures in the ocean or the seas. Okay, so let's go and we need to read this statement, which tell us also another factor that affect the living creatures and affect also the pressure of the liquids. Yes, the pressure inside water also increases with the increase in water density. Therefore, water pressure at a certain depth in seawater will be greater than its pressure at the same depth in a freshwater lake, having lower portion of salt. So the density here also it is a key point which affect the pressure of the liquid. So the salty liquid which has higher density than the fresh water, okay, it has higher pressure, and that also will affect the living creatures inside the oceans or the seas. Okay, I hope that's clear for all of you, my dear student. Let's continue. The pressure at the sea level. This information is very important for all of you. Why? Because here, don't forget, the water pressure increases by approximately 1 atmospheric pressure for every 10 meters below the water surface in the sea. Okay, I want you to keep this in your mind. I will repeat that again. The water pressure increases by approximately 1 atmospheric pressure or 1 atom for every 10 meters below the water surface in the sea. Okay? Now, my dear students, let's go for the core of our lesson. And I will remind you again with the title of our lesson, the effect of water pressure on organisms. So here we will know how the pressure affects the living creatures. So the title here will be Effects of Pressure on Biological Adaptation of Marine Organisms. Let's start by the surface organisms. That already we can see it near to the surface of the seawater or the ocean water. Organisms that live near water surface face a relatively low water pressure, and therefore their physical structure is less strong compared to the organisms that live in the depth. That's right, because in the depth the pressure will be higher, so the physical properties and the biological properties of the living organism sure will change from place to another or from depth to another inside the seas or the ocean. So the surface organisms that live near water surface face a relatively low water pressure and therefore their physical structure is less strong compared to the organisms that live in the depth. That's right. Also, organisms at intermediate depth, okay, sure, it will have it will have a different properties. At depth from 200 meters to 2000 meters, this is called by intermediate depth from 200 to 1000 meter. Okay, living organisms are more specialized to deal with increasing pressure. Okay, so the physical characters or the physical properties, the physical features of the living organism should be changed according to the pressure change. Okay? And now let's go to study how the pressure affect the living organism. Let's talk about an example like the air bladder or swimming bladder. Okay, some fish have swim bladder filled with gas that help them control their buoyancy and balance in water, or to move between different depths during their migration between areas and between seas and rivers, such as salmon fish. So here, the presence of the bladder or swimming bladder, it is affected sure by the pressure. So the organism at intermediate depth, okay, like the salmon, it has what? Yes, a bladder that help in the buoyancy and to control their direction up or down. Okay? What else? Organisms at great depth. And really, we need we need to know more about this kind of creatures, which found at a depth more than 2000 meter. And at 2000 meter, the pressure it is extremely high pressure. Okay, organisms that live in this environment are often characterized by compact body structure. And the compact body structure here means it's a strong body and compressed body, okay, which contains protein component and internal fluid that withstand high pressure. So the more pressure affect the body of living creatures, okay, the more compacted their body will be. Okay, don't forget that. So here we need to confirm the relation between the pressure and the adaptation of the living organism. Okay, organism at a great depth also. Some of these organisms, such as rice fish or ray fish, don't have gas bladder to ensure they don't collapse under such high pressure. Imagine if the ray fish, okay, has a bladder or a swimming bladder contains gas. Under this high pressure in the deep ocean, okay, the gas will be exploded or the gas bladder cannot withstand the high pressure, so it can be exploded. So it is replaced by what? By liquid. Okay, let's go to see that. Also, they have a bladder that contains what? Yes, it contains liquid instead of gas and rely on a large oil-rich lever to increase their buoyancy and control the depth. Okay, so this is a kind of adaptation to withstand the high pressure. It's not high pressure. Oh no, it's extremely high pressure because we talk about a depth more than 2000 meter under the sea or the ocean surface. Okay, I hope this is clear for all of you, my dear students. And let's now go to another thing. The second, bony and cartilaginous skeleton. Okay, let's compare between them to know how both of them affected the living creatures and make it, yes, withstand the extremely high pressure. Bony fish or ostrich thigh fish, okay, such as tilapia fish and mullet, are characterized by having a skeleton made of bone. Okay, so it provides strong support for the fish body and stabilizes the body under various pressure such as water movement or water pressure. So the bony fish or the bony skeleton, okay, that help the living creatures also to withstand the pressure, okay, but which one is better, bony or cartilaginous skeleton? Which one is more adept with the high pressure? Let's go to know that. Cartilaginous fish or chondriothies fish, such as shark and rai, are a group of fish characterized by having cartilaginous skeleton instead of bony one. And I want you to think deeply and carefully. Which one is better? To have a strong and bony skeleton in the high pressure, extremely high pressure, or having a cartilaginous skeleton? Let's think together to know the difference between them and which one will be suitable for the areas of high pressure. Okay, look to the shark and ryefish. Both of them have what? Yes, cartilaginous skeleton. Okay, and cartilaginous is more flexible and higher, yes, and lighter tissues compared to bone, which gives, yes, cartilaginous fish the flexibility and the distinguishes them from the bony fish. So the cartilaginous skeleton, okay, it is more flexible than the bony skeleton. Okay, that's very clear, and I hope all of you to understand the concept that I mentioned before. Okay, and now, my dear students, let's go for the third thing. Yes, the cellular membrane. Okay, and how the cellular membranes affected by the high pressure or the extremely high what? High pressure. Okay, deep sea fish have developed unique adaptations in their cell membranes to withstand the immense or the extremely high pressure at a great depth. So even the cellular membrane, according to the pressure, okay, it is already changed and adapted with the high pressure. Okay, look to this statement, and this is achieved by increasing the levels of unsaturated fatty acids in the composition of their cell membranes. These fatty acids help maintain the fluidity and stability of membrane under pressure, prevent cell damage. So even the cell membrane change, and that will help the cell from what? From damage. Okay, this is very important. So we talk about three important things. The third one, it is a cellular membrane. Okay, and also we'll talk about what? About the skeleton of the fish and how it's helped the fish to withstand what? Yes, to withstand the high pressure. And also we'll talk about the air bladder, okay, or the bladder inside the fish and how the gas is replaced by the liquid. Why? To withstand the extreme high pressure. Okay, the lesson today is very easy, but we need to study it carefully, especially after finishing the epithought. Okay, so now, my dear student, I want all of you to pay attention with me and follow me in checking our understanding. If you know to understand, let's go for the exercise. Choose the correct answer. Yes, I want all of you to read with me. Water pressure increases by approximately blank for every 10 meters above the surface. 1 Pascal, 10 Pascal, 1 atom, 10 atom. Yes, do you remember the information that I told it before in the lesson? Okay, yes, the answer will be 1 atom. Again, water pressure increases by approximately blank for every 10 meters below the surface. The surface, sure, the surface of water or the surface of seas, ocean. So the right answer here is 1 atom. Okay? Let's go for another question, my dear student. Please leave everything in your hand, look carefully to the screen, and follow me. What is the main function of the swim bladder in fish that live at intermediate depth? Let's go for the choices. Producing heat to maintain body temperature, assisting in digestion, controlling buoyancy, stronger oxygen respiration. Again, what is the main function of the swim bladder in fish that live at intermediate depth? Reducing heat to maintain body temperature, assisting in digestion, controlling buoyancy, storing oxygen for respiration. Sure, the answer will be controlling buoyancy. Okay, because the swimming bladder help the fish to go up or down. Another question, my dear student. How do fish that live at great depth adapt to high pressure? The choices: by increasing the size of their swimming bladder, by filling the swimming bladder with liquids instead of gases, by increasing their heart rate, by increasing the size of their gills. Yes, you are right. By filling the swimming bladder with liquid instead of gases. Okay, why? Because the gases, if the bladder is filled with gases, it can be exploded under the high pressure in the deep oceans. Another question: what is the importance of lipoproteins in the cell membrane of marine organisms that live in the depth? Okay, the choices: they increase membrane rigidity, they increase membrane flexibility, they increase membrane permeability, they reduce membrane surface area. Good. You are intelligent student. Yes, they increase membrane flexibility and that help in withstanding what? Don't forget, yes, the high pressure in the deep oceans. Another question: which of the following can follow and take the shape of the container? Yes, that's right. The solid and liquid, solid and gases, liquid and gases, solid, liquid, and gases. Okay, my dear student, that's very nice. This is the right answer, liquid and gases. Okay, let's go for another question, my dear student. Which of the following can be compressed easily? Solids, gases, liquids, solid, liquids, and gases. Yes, that's good. Gases, it can be compressed, okay? But liquid or solid, sure, cannot be compressed. Another question: which of the following are measuring unit of the pressure? Newton per meter square and joule, Newton per meter square and atom, joule and atom, Newton per meter square, joule and atom. Excellent. Yes, that's right. Newton per meter square and atom. Okay? Let's go for another question. I want all of you to read carefully. If the pressure at a point inside liquid equals 4.052 times 10 power 5 Newton per meter square, then it's equivalent to 1 atom, 2 atoms, 3 atom, 4 atom. The answer will be, we have to divide it. The value of the pressure, which is 4.52 times 10 power 5, divided what? Yes, the standard atmospheric pressure at the sea level, which is equal 1.013 times 10 power 5. So the answer will be for atom. So the right answer is for atom. Okay? I think it is clear for all of you. Another question, my dear student. Okay? Fluids includes blank substance, solid and liquid, solid and gases, liquid and gaseous, solid, liquid, and gaseous. Yes, the fluid includes excellent liquids and gases. I mentioned that before. I told you in the first part of our lesson when we talk about the concept of the fluid. Fluid includes liquid and gases. Don't forget. Another question, my dear student. A liquid has a pressure at any point inside it equal to the blank of the liquid column above the point acting on the unit area of that point. Density, volume, weight, mass. Yes, try to think because there is very, very important concept we have to know here. Yes, it is the weight of the water above that point. Okay, let's go for another thing. What is the main advantage of cartilaginous skeleton in fish like sharks? It provides greater strength. It provides greater flexibility. It makes the fish heavier. It provides no special and advantage. Sure, the right answer will be it provide greater flexibility as we mentioned before, because the cartilaginous skeleton, okay, it has more flexibility than what? Yes, than the bony skeleton. Okay, I think that's very clear. Another question. All the following are properties of gaseous substance except the ability to flow, has a definite volume, to compress easily, take the shape of the container. Let's go for the answer 1, 2, 3. This is the right answer. Yes, has a definite volume. Okay. All the following are properties of liquid except no ability to flow, has almost definite volume, resists compression, takes the shape of the container. Yes, you are right. No ability to flow because the question is what? All the following are properties of liquid except what? No ability to flow. Good. Another question, and it's a tricky question. We need to concentrate more in this question. If a set of containers are filled with water as shown in the figure, the correct order of points A, B, C, D according to the pressure is, yes, I mentioned before, the pressure increased by increasing the depth. So which point expected to has the highest pressure? Sure A, because it is the deepest one. Next, C, then B, and finally D because it is in the surface. So the pressure there, it is approximately equal the atmospheric pressure. Okay, so the right arrangement will be pressure at A greater than C greater than B greater than D. Okay? Okay, my dear student, let's now go for the essay questions. Give reason for. Photosynthesis mainly occur in the surface layer of the ocean's water. Why? Yes, due to the availability of the sunlight. Ray fish has a bladder containing liquid instead of gases. Why? Good. To increase their buoyancy and control the depth. Okay, and also the liquid will make the fish to withstand the high pressure in these areas or that deep depth. Give reason. Organisms that live at great depth are characterized by compact body structure, protein component, and internal fluid. Yes, the answer is very clear. To withstand high pressure, because our lesson today is about how the living organism adapt with the pressure inside the seas or oceans. The organisms that live near the water surface have physical or body structure is less strong than those that live in the depth. Good, due to the low water pressure at the surface. Okay, at the surface, the pressure is very low. It's not compared with the pressure at 2000 meter deep in the ocean. Okay, another question. The diagram shows 3 points, 1, 2, 3, at different depth below the surface of the water. Rank the pressure exerted at each point from the lowest pressure to the highest pressure. Okay, so B1, it has the lowest pressure. Why? Because it is the lowest depth. Then B2, then B3. Okay, my dear student. Okay, let's go for the final question. The diagram shows two containers with different liquids. If we know that the density of the liquid X is greater than the liquid Y, when the height of the two liquids is held constant as shown, which of the two liquids exerts on the space of its container with more pressure and why? Okay, that's very good. Liquids X because the liquid pressure increases by increasing the density of the liquid. Okay, okay, my dear student, this is the end of our lesson for today. I hope all of you understood well. See you later and goodbye.